Hey, Gary Simmons here for the Game Institute, and welcome back to lesson 34 of the Dead Earth game development series. In this lesson we are going to continue to develop our zombie damage system. Now, in the last lesson we added the take damage function to the AI zombie state machine class, and this function would turn Jill into a ragdoll if she was hit by a weapon that had some force that needed to be applied to a ragdoll, or if the attack caused her health to drop to 0. In both cases we would see her ragdoll. Now, when we ended up at the end of the last lesson, we still had a console window filled with a load of errors, where Unity is complaining that we've got a viewing vector being generated, and if you look down here you can see it's being generated in this particular case in the pursuit state class, and that viewing vector has a length of 0. Now, that was a little bit of an oversight on my part, so let me explain to you why this is happening. So if we go to the AI zombie state pursuit class, which is the state which is giving me all of those errors, you can see that at some point in the update function we generate a new look quaternion by using the quaternion look rotation function using the zombie state machine nav agent's desired velocity vector. The problem is, if I go back over to my AI zombie state machine class, one of the things we do in that take damage function when she gets hit is we set the speed of a nav agent to 0. When we set the speed of a nav agent to 0, the nav agent doesn't want to go anywhere, therefore it doesn't have a desired velocity. In other words, it has a desired velocity vector with a magnitude of 0, and that is why we are getting that error. So what am I to do? Well, don't worry about it. This line of code that I added at the last lesson was a completely terrible idea. It shouldn't be there at all. I'm just going to cut it out. I think I got a little bit confused because in the past I had a system implemented that didn't use root motion, and I would use the zombie nav agent's speed property like that to actually stop and start the nav agent. But of course we don't have to do that now because our nav agent gets its velocity set directly from the root motion in the animation. So in the case where she ragdolls, that's not a problem because we turned the nav agent off, and in the case where she doesn't ragdoll and we want to play like a hit back animation, then that animation is going to control the speed and the velocity of the nav agent anyway. So let's take that out completely, and that will get rid of that problem. However, what it will do is it will generate a load of other problems. Well, actually that's not true. It won't generate a load of other problems. We'll just start to see a load of other problems that we didn't know were already there. But they're easy to fix too, but let me just show you what the problems are. So if I walk up to Jill and then I shoot her into a ragdoll, now look at the console window. I'm going to pause the game so we can see what it says. It's complaining about us calling the set destination function of the nav agent and the resume function of the nav agent. It says that these functions can only be called on a nav agent that is active, that is enabled, and of course once we ragdoll Jill we disable her nav agent. So if she was in the pursuit state, for example, the pursuit state would still be running, the nav agent wouldn't be going anywhere, but the code that we write, our pursuit state, will still be executing. And in the on enter state function you can see we tell Jill to navigate to this position and then to resume along that path, and of course these functions are not allowed to be called because the nav agent is not enabled. So what we need to do is, we started to do this a little bit in the last lesson when in the should ragdoll conditional we set that in melee range to false, but I didn't really finish that off. So what we need to do also is completely clear the current state of Jill, and when I say state I mean that's our state machine. So if a current state, for example, was alerted, or if a current state was pursuit, we need to make sure when we ragdoll we just set a state to none, and that's important because you'll notice that if I set her current state to none and then jump back into the AI state machine base class's update function, right there at the top of the update function we say if we don't currently have a state then we return, and we don't do any of our own state machine processing, which is exactly what we want. We don't want to be calling states to do something when Jill is in a ragdoll, because those states are going to be trying to tell the nav agent to do things and the nav agent can't do anything yet. So all we have to do is go back to our AI zombie state machine class. We want to set the current state to null, but we don't just want to make that assignment, because if we are in a state already, our states have that on exit state function, which allows that state to do any cleanup in this situation. So we'll get the current state, we'll let its on exit state function execute so it can do any cleanup itself, and then we'll set the state to null. So first of all we'll check that we do actually have a state reference, the current state that we're in, and then if we do have a state we will call that state's onExit state function, so it's cleaned itself up. We've come out of that state in the correct manner. Then we'll set the current state reference to null, and we'll also set the current state type enumeration to AI state type none, just so those two things mirror each other. And that should pretty much solve those problems, because we're basically saying when we are in a ragdoll situation, we're going to make sure that our whole state machine logic doesn't execute anymore. And just to labor the point, that is because in our AI state machine base class in the update function, we just don't do any of the state machine processing or call any of the individual states functions if the current state is set to null. So this will work perfectly. And of course, later on, when we wish to reanimate Jill, we're going to need to make sure that we once again assign her a state, enable all of her animator and her nav agent components, and kick this thing off again with a valid state. And I think, I mean, this is some way off, but I think when I bring her out of a ragdoll state, I put her into an alerted state. And that makes perfect sense to me, because if a zombie gets shot in the back and falls over, when it gets back up, it might not know where the shot came from, but it's going to be pretty alert, right? It's going to be aggravated. But if I save all this off now and go back to the editor, clear the console window, and then press play, I'm hoping now that all the errors will be gone. So there you go, I've shot her. We're getting none of those complaints that we've got a zero length view vector. And now I'm going to ragdoll her and check the ragdoll errors are gone too. And remember, when she was ragdolled, that's when we started seeing all of those errors that was complaining that we were trying to call the resume and the set destination function on a disabled nav agent. They've all gone now, because well, now we're in a ragdolled state. None of our kind of state machine logic is really executing. Okay, so what we're going to do now is we're going to implement the hit layer in Jill's animator. And this hit layer is going to contain animations that will play whenever Jill is attacked, but that attack doesn't cause her to go into a ragdoll. So that's going to contain animations that will play when she is, let's say, shot in the chest by a bullet that might not do 100% damage, or if we're in a melee attack and we're smacking her about the head with a crowbar, we don't want her to just ragdoll all the time unless we've done real damage to her brains. So that's what this animation layer is going to be used for. And in our take damage function, when we detect that we don't want her to ragdoll, we're going to choose the correct animation to play on that layer based on the type of attack that it is and the direction of the attack. And then when that hit layer plays, its animations on there are going to override anything in the layers underneath it. So even if the zombie was in a pursuit state and was running towards you, as soon as a hit layer animation plays that has her stepping backwards, under the force of a projectile hitting her in the chest, for example, that step back animation will overwrite anything on the layer underneath it, and it's that animation that will be giving the root motion to Jill's nav agent. So to better explain what we're going to do next, I'm going to switch back just for a moment to the current production version of Dead Earth. And I'm going to call up OmniZombie Jill's animator. And if you look in at animator, and I've got the layers tab selected here, you can see there are several layers created here that we have yet to create in our zombies animator. And we'll get to the lower body and the upper body layers later on when we start implementing the damage. We just have the base layer, the attack layer, and the cinematic layer at the moment. And if I select the cinematic layer, our cinematic layer currently doesn't look anything like this. It just has the zombie eating intro, the zombie eating loop, and the zombie eating outro. But we'll get to that in good time. Most of this stuff here is all to do with reanimating the zombie from a rag doll. But what I want to concentrate on for now is the hit layer. The hit layer is a layer that is invoked when the zombie takes some damage and isn't going to ragdoll. So it's on this layer that we're going to have animations that will see, for example, if we shoot the zombie in the chest, the zombie stepping backwards, or if we hit the zombie over the head from left to right, we'll see the head be knocked from left to right. And of course, because the hit layer is above the base layer, we know that any animations on that layer when playing will override anything in the base layer. And also you can see that our hit layer doesn't have a little M next to the cog, which means it's not using an avatar mask. So when the animations in this layer play, they completely commandeer the skeletal hierarchy of Jill and override all of the bone information that may be trying to be played on the base layer. We'll talk a little bit about what these animations are in a moment. It's very simple. But notice how each of these animations are attached to the any state state. Now remember, this is a way for us to transition to any of these animations instantly if the conditions met in these transitions are true. So it doesn't matter what we're doing on the base layer, if we set some trigger that causes these transitions to be triggered, then they will immediately happen, overriding anything on the base layer, which is of course exactly what we want for our hit layer. The other thing that's really important, and we've discussed this before, is that the default state, remember this is the state that shows up orange in the animator window, is an empty state. It's got nothing in it. And this is important because we know that if you have multiple layers in an animator, one animation state has to be playing out. And therefore, because we only want the hit layer to do anything when we are in the middle of playing a hit animation, by default, when we're not in the middle of playing a hit animation, we just have this empty state which does nothing and doesn't override the bones of any of the animations in layers underneath it. Okay, so let's talk a little bit about how this hit system is going to work. Now, let me first of all say that some of the decisions I've made have been based on the limited resources that I have to work with. I don't have the ability to make all of the animations from and to every combination of thing that the zombie might be doing. So for example, when the zombie is crouched down on the floor feeding, I don't have an animation that if we shoot her in the side, we'll see a sort of lurch to the right or the left from a crouched position. So what I do is I say that when Jill is in any of those kind of cinematic animations, whether she's feeding or whether she's crawling, if she takes a hit in that position, she will instantly ragdoll and this hit layer won't be used. Furthermore, I don't have any animations that allow the zombie to be pushed forward if we were to attack her from behind. So once again, I just say that if we shoot our zombie from behind, she always ragdoll. She'll always fall down. She'll get back up again. Although I'm doing this because I am kind of resource limited, I also don't mind making that compromise because it seems to me that, you know, a zombie that you're attacking front on would be more braced for impact and would be more expecting of a hit coming and therefore more likely to stay on its feet. Whereas if you hit it from the back, it's going to be a completely unexpected blow and the zombie will fall over and ragdoll. So there's this kind of strategy here where if you're trying to get away from something, there's actually a benefit from trying to sneak up and hit it from behind because you will at least knock it down. You might not kill it, but you'll knock it down. Also, I made a decision in Dead Earth to have some kind of strategy in the way that we attack zombies. So obviously if you shoot a zombie in the head with a powerful gun, then it's going to be a headshot and the zombie is going to die and ragdoll instantly. If you hit the zombie in the head with like a crowbar or a nail bat and it doesn't do fatal damage, then what will happen is the zombie will either be knocked backwards or its head will be knocked to the left or right. And one of these three animations in the top row here that we see on the screen will be played, and we'll drill down on the details of that in a moment. With respect to launching attacks on the upper body of a zombie, well, as discussed, if we hit any zombie from behind, irrespective of the body part and the damage caused by the weapon, the zombie is going to ragdoll initially. It's going to fall over. But of course, it may get back up again if its health isn't zero. If we hit a zombie from the front and the zombie isn't killed by the attack and the weapon doesn't produce a force, then what we'll play is one of these animations on the second row that we see on the screen here. And that's going to be either a kind of a step back or a step left or a step right. So if you look at the way that the animations are laid out in this animation pane, the top row describes the three animations that we're going to play if the zombie is hit in the head from the front with a non-fatal blow. The second row describes the pre-canned animation that's going to be played if we launch an attack on Jill's upper body, her torso, from the front, and it's a non-fatal attack also. So the top row will see the head being either knocked left, knocked back, or knocked right. And on the second row here, we will see if she's hit in the body, the whole zombie is going to either step back into the left, step straight back, or step back into the right. Notice though we don't have a third row to describe what happens when Zombie Jill is attacked in the legs, and that's because I made the decision that leg shots can be quite tactical, and if you shoot a zombie in the leg, you're always going to take its balance away and cause it to ragdoll. So if a zombie's chasing you, then shoot for the legs if you don't think you can get a headshot, and that will at least knock her down onto the ground, giving you time to escape while she's getting back up. So how are these animations played? Well, they're going to be launched from the take damage function that we added to our AI Zombie State Machine class in the last lesson. And it does that using two parameters that we've already added to our state machine, but we've never used. Now remember, at the moment, I'm looking at the production version of the animator for Jill. So our parameters list doesn't look as big as this yet, and some of the names may be different. But what our animator does have is it has these two properties here. It has a trigger called hit and an integer parameter called hit type. And just to show you what I mean, if I go back to our Zombie Jill and I call up her animator, you can see there is the hit trigger and there is the hit type integer. Like I said, they're not being used at the moment because we don't yet have a hit layer. So if I go back once again to the production version of the project, so we can see those hit animations laid out. So the way this is going to work is actually really simple. Each one of these animations in its transition just has an integer assigned to it. So we might say, for example, Z1 hit left has an ID of 1, take 001 has an ID of 2, Z1 hit right has an ID of 3. In our take damage function, once we determine that Jill shouldn't be ragdolled but instead a pre-canned animation should be played, we're going to calculate where the attack is coming from. So if we get hit in the left shoulder, we want to play the zombie torso hit back left. If we're hit in the right shoulder or the right side of the body, we want to play the zombie torso hit back left. Now, I know that says left, but you'll notice if I select that one, I've mirrored that animation state, so it actually gives us a hit back right. But in the production version, I've done a very lousy job of actually giving my animation states meaningful names, but when we create this layer in a minute in our version, we will give proper names to this, which makes it easier to read. So our take damage function, based on the body part that's been attacked and the direction vector of the attack, is going to set this hit type to one of these 6 integers to trigger the correct animation, and it will then set this hit trigger. If I select the transition from any state to this hit left animation, you'll notice that the conditions are simply that, assuming we're not feeding or crawling, because we never transition to anything when we're feeding or crawling, we're just going to ragdoll in that case, and assuming the hit type equals 1, which is something we'd set in our take damage function, if the hit trigger's been set, then transition to this animation. And you'll notice the transition back into the null state, if you like, has the has exit time boolean tick. So what we're saying is, if our take damage function sets hit type to 1, sets the hit trigger, then we are going to transition into this hit left animation clip, which is going to play out till its entirety before then we transition back into a null state, and then whatever is playing underneath it on the base layer will once again resume control and be in full control of Jill's bone hierarchy. So just to show you what I mean, if I select this transition here to the first top left state, you can see the condition is if hit type equals 1. If we go into this middle state, we say if hit type equals 2, and if we go into this third state, we say if hit type equals 3. If we transition to this fourth state, it's hit type equals 4, and well, I'm sure at this point you get the idea. Hit type equals 5 and hit type equals 6. So that's all our take damage function has to do, has to set that integer as an animator parameter and then set the hit trigger, and the animator will do the rest. Okay, so now we understand how this is going to work. Let's go back to our version of Dead Earth and let's set up Jill's animator. And of course the first thing we have to do is we have to add that layer, which remember needs to live between the attack layer and the cinematic layer. The reason it's after the attack layer is obviously if the zombie is attacking us and it's in the middle of an attack animation and then we smash it in the face with a crowbar or we shoot it in the head, we want the hit layer to override anything that's happening in the attack layer as well. So let's add that new layer to Zombie Jill's animator. Now, just in case you haven't got your animator window open at the moment and you've forgotten how to get there, what I like to do is just select Omni Zombie Jill, select her AI entity game object, then go to the window menu and choose Animator. And what we'll do is make sure we've got the layers tab active, and we'll click that little plus sign, which will create a new layer at the bottom of the layer stack. We'll change the name of that layer to hit, and then we'll move it up so it is between the attack layer and the cinematic layer. Then we'll click on the little cog icon to bring up the settings, and we want to move the weight all the way up to 1 so that the animations playing on this layer will completely override all of the layers underneath it, so there won't be any blending. And we don't want to use an avatar mask because, like I said, we want the animations on this level to completely commandeer the skeleton of Jill. And we also want to have the blending mode on override, which is the default. Okay, so let's now look at some of the animations that we have in our animation library that we can use to set up those 2 rows of 3 animations. And remember, the top row is going to be the left head hit, the center head hit, and the right head hit. So if I drill down into my Dead Earth folder, my animations folder, and my Game Institute folder, and then drill down into the damage subfolder, you can see here that we have an animation called Zombie Face Front. So let's play that and see what that looks like. I don't know if, yeah, let's use that one for when we punch her in the face. So we'll drag that one into the center there. Going back to the damage folder again, we also have a zombie hit face left. Hey, that's perfectly what we want. So let's put that on the left hand side of the top row of animations. And going back to the damage folder again, we also have a zombie face hit right or hit face right. And let's just remind ourselves what that one looks like. Perfect. So you can see if we were in the middle of a melee battle and we decided to swing our crowbar so that it was swinging from right to left, this is the animation that would be played, and it would look like we've knocked the head of the zombie to the right. Okay, so that's the top row of animations done. That's the pre-canned animations that will be played when we've dealt a blow to the zombie's head from the front, and in situations where that blow doesn't cause a ragdoll to happen. The second row of animations here needs to be another 3 animations that are basically the same thing, a left, a center, and a right animation, but this time for blows to the torso, the upper body. So we have a couple here we can choose from. We've got one here called Zombie Hit Knock Back. That's not bad. And we've got another one I think called Zombie Hit Chest. I think I like that one better, and that's a very central blow, so you can see if we, yeah, I think that's what we want. If we shot the zombie in the chest with like a very unpowerful weapon, she might just do that. So let's drag that into the middle of the second row. And then we also have 2 animations here. They're actually not named in the correct way. They're actually called zombie head hit to the left and zombie head hit to the right, but I think we should use these for the body hits to the left and right. So that there would be a hit to the left shoulder. And do we have one for the right shoulder as well? No, that's also kind of a left hit as well, isn't it? What we'll do is we won't use that one. We'll use the zombie head hit to the left, that one, because I like that one. And then we'll just mirror it on the right. So I'll drag that one in there, call it zombie head hit left. And I'm going to select that state and rename it. And I'm going to call it zombie body hit left. Okay. And then I'm going to drag that animation in again on the right hand side. I'm going to select that second version of it. I'm going to call that zombie body hit right. And I'm going to choose to mirror this animation. So it's going to be the complete symmetry of the left hand side, and it will have her lurching to the right. Okay, so one of the problems we've got at the moment is the first animation state that we added, zombie hit face front, is lit up orange here, and that means it's the default state. And we don't want any state really to be the default state, because the default state of the hit layer is that it should be doing nothing at all. So I'm going to create a new state by right-clicking in some empty space, going to create state, and choose to create an empty state. With that new state created, I'm going to right-click and I'm going to choose set as the layer default state. And now, if we were to add no transitions, this would always be the state playing on the hit layer, and the hit layer would never influence Zombie Geoskeleton at all. It would never override any animations in layers underneath it. So now let's make some transitions from the any state. So I'm going to do make transition to there. I'm going to hook up all the transitions, then I'll go back and visit each transition afterwards, and I will fill in the proper conditions under which the transition should be executed. And then we want to go from each of these states back into the empty state when the animation has finished playing. So it's going to look a bit spiderwebby, but hopefully you can see what's going on. We've just got from any state to every state, and then we've got every state to the empty state. Maybe I'll move them a little bit out like that, just so I can see the different wires easily enough. Okay, so first of all, let's do the easy step. Let's select all the wires that go from our animation clips to the new state, because these transitions have no conditions. The only condition they have is that has exit time is set, and I think that's the default anyway, isn't it? Yep. Yep. Notice I'm just checking all of the animation transitions that have the arrow pointing towards the new state. So the one I've got selected now is from zombie hit face right to that new state, and all of those to the new state have no conditions whatsoever, but very important, they do have has exit time ticked, and that basically means that this transition is only going to happen once the animation that we're transitioning from has played out its full animation. Okay, so let's now visit each of the transition wires from the any state to our individual animation states and set the appropriate conditions. So for zombie hit face left, if we call up our parameters and then select that transition again, we can see that we want this to be invoked when the hit trigger has been activated and when hit type equals 1. So let's add those two conditions there. So we'll say if hit, and we don't have to set hit to anything because hit is a trigger. So it's not even like a boolean that's true or false. It's just when you set a trigger, it will cause that trigger to be set in the animator for 1 frame, and then the trigger will unset itself again. And we don't have to worry about like resetting it back to false like we would have to with a boolean. And with the hit type condition, we will say if it equals 1. The next transition is from any state to zombie hit face front. We will add two conditions. Once again, the first one is simply that the hit trigger is activated, and the second one is that hit type equals 2. Okay, what do you think the conditions in this one are going to be? As you've probably guessed, the hit trigger has to be set, and hit type equals 3. And now I'm going to do the transition from any state to the zombie's head hit left. Oh, head hit left, I should rename that. That should say zombie body hit left, of course. So I'm going to rename that one before I forget. There you go. I'm pretty sure I did that earlier, right? I guess I never pressed return and committed it. Okay, so I'm going to select the transition from any state to zombie body hit left. And once again, two conditions, hit and hit type equals 4. Where's the wire for this one? There it is. Just so you can check, it's this one here. Okay. Thought I'd move it out of the way just because you can't see the arrow. But this is the transition linking any state to the middle body hit. So once again, two conditions. First one being hit trigger is set. Second one being hit type equals 5. One more to do. And that is of course this one here, from any state to zombie body hit right. Two conditions once again. First one being the hit trigger. Second one being hit type equals, go on, have a guess, go on, have a guess, 6. Yeah, that's right. Okay, so I think this is actually set up now correctly. What we haven't done yet though is we haven't added any root motion configurators to our animation clips to tell our animation state machine that we're using root motion, because all of these animation clips, as you can see, they do use root motion. Just to double check, if I click on, I don't know, what should we say, the chest hit, you can clearly see there is root motion encoded in the animation. So let's select the first one, do add behavior, do root motion configurator. Second one, add behavior, root motion configurator. And we're going to do this for all of our animations, but not any state or new state, okay? So once again, motion configurator. We'll go back in a minute, visit all of these and set the correct values for root position and root rotation. Okay, so we now have a root motion configurator on our 6 animation clips. Let's go back now and set the root position and root rotation properties of each one. And I think for all of these states we will just set root position to 1 and root rotation to 1, and we'll do that for every one of our animation states. I think that should be fine. I think we want, looking at the animations, I think we want root motion and root rotation to be used by all of them. Yep, and then the final one, 1 and 1. So I think ZombieJill's animator now is completely set up. The hit layer is ready to be used. So that was done pretty quickly, wasn't it? Of course, whether it all works is anybody's guess. So it's time now to jump into our AI zombie state machine and add the code now that's going to use this layer. Actually guys, before we jump into the code, I just watched the last section of video I recorded back. I noticed I made an error in the transition from any state to this third animation clip. Obviously the condition for that should be when hit type equals 3, but I forgot to change the condition from greater than to equals, so I'm going to do that now. I'm glad I caught that, because things like that can be absolute murder to track down and debug. When your animations aren't working right, you tend to think that it's an error in your code and you're combing over your code, and then it turns out it's just you forgot to flick this little drop down box to the correct condition type. So obviously all of those should say if hit type equals and then a number through 1 to 6 depending on the animation clip. Okay, so let's open up our AI Zombie State Machine class now in MonoDevelop. Okay, so the first thing I'm going to add to the top of this file is going to be a new public enumeration that I'm going to call AI Bone Control Type that looks like this. As you can see, it has three members: animated, ragdoll, and ragdoll to anim. We're going to use a member of this type to keep track of whether our zombie is currently having its bones controlled by the animation system, in other words, the animator component, or whether it's having its bones animated by the physics system, which is the case when our zombie is in a ragdolled state. Finally, either in the next lesson or the lesson after, we're going to implement our zombie reanimation system. That's the system that's going to allow us to blend from a ragdolled state back up into an animated state. And as this takes a short period of time, we're also going to want to have a third state, which I've called ragdoll to anim, so that our zombie knows when it's in this transition phase. So we're also going to need to add a member of this type to our AI zombie state class. Doesn't need to be public, we'll just make it private. So we'll put it under our private variable section, but I'll put some comments here that says this is the ragdoll stuff, because we're going to be adding lots of variables here eventually to control when we're going from a ragdoll to an animated state and vice versa. So this needs to be a private member of type AI bone control type, and I will call it bone control type. And of course the default is to have it set to AI bone control type .animated, so that when our zombie is first created at scene startup, it is being controlled by the animation state machine. The next thing I'm going to add is some more serialized variables that I'm going to use to control how much damage has been done to the upper body and how much damage has been done to the lower body. Now, once again, we're not really going to see the upper damage and the lower damage play out graphically yet until we add our upper body and lower body animator layers, but we are going to be keeping track of how much damage has been done to the zombie in those areas. Now, something that's worth me mentioning at this point is in Dead Earth, I made the decision that the zombie's health is the health of the zombie's brain. Therefore, you can shoot a zombie in the legs or in the body as much as you want. It will never affect the zombie's health. The only thing that will affect the zombie's health is damaging the head, damaging the brains. So you might be thinking, well, what is the point then of having upper and lower body damage? Well, if you cause 100% damage to the zombie's legs, it will no longer be able to walk and it will instead start crawling after you. If you cause 100% damage to the upper body as well, then the zombie won't be able to crawl after you either, and it will just be led on the floor, but it will still be wriggling because it won't actually be dead. So it's really cool because we can stay true to most zombie fiction, whereas only a headshot will actually kill a zombie. But you still can, of course, influence the efficiency at which a zombie can come after you by damaging its legs or its body. So I'm going to create these two new variables called upper body damage and lower body damage underneath where I defined our health variable, and they're going to be pretty much the same thing. That is, they're going to be serialized fields. We want them to show up as a range slider in the inspector. They're integers. I'll call this one lower body damage, and we'll set that to 0 by default. And then we'll add the second one, exactly the same, it's an integer, and we want it to show up in the inspector as a range slider between 0 and 100% damage. So this kind of works in the opposite way to health, right? Health goes from 100 down to 0, whereas damage goes from 0 up to 100 as that particular part of the body becomes more damaged. And I'll call this one upper body damage, and we'll set that to 0 by default as well. So as you can see now, if you look in the inspector of Jill's AI zombie state machine, you can see we have the lower body damage slider that allows us to set a value between 0 and 100, and the upper body damage slider, which allows us to do the same. Now you might be wondering why we need to be able to set these in the inspector, because isn't damage something that just accumulates as the zombie lives its life in the world? Well, that's true, but we're also able to set the initial damage of the zombie, and you'll see later on when we set up our upper body and our lower body damage layers, by setting up these sliders at startup, we can control whether a zombie already starts in a damaged state, whether a zombie starts off only being able to crawl or only being able to limp when it runs after you. So that's why we have them exposed as inspector variables. But of course at the moment they don't do anything. It's also worth remembering, although we haven't really used it yet, in our base layer, in our animator, you can see we have this crawling locomotion, which at the moment we don't have any state logic that causes us to transition into that. Of course, later on, this is exactly what we're going to go into when we have sustained serious damage to the lower body. We'll only be able to crawl. And that's going to happen by that take damage function. When it realizes that we've accumulated damage to the lower body past a certain threshold, it's going to set this crawling boolean to true in our parameter list in our animator. And you can see actually, even if I was to do this now, let me just move the game window down to the bottom for a second. Without doing anything, just set Jill's crawling parameter to true, and I'm going to call up the scene view so we can see what happens. When we press play now, Jill will start off in a crawling state. There she is, crawling to her next waypoint. Pretty cool, huh? Bear in mind this is in the scene view, guys, so it looks a bit looks a bit crappy. So you can see that eventually, once we've hooked up what those sliders tell us in Jill's Inspector, and we set those parameters in the animator based on that, we'll be able to just say, hey, if we want Jill to start off in a crawling state to begin with, we can set a lower body damage up to some number that's past some minimum threshold that we specify. But we don't really need to do any of that just yet, because at the moment we're not going to be creating that damage system that's going to exhibit the different ways that Jill can either crawl or limp. But we just want the values in there for now, so that when we go back to the take damage function, we can actually accumulate that damage. And then in the next lesson we will look at starting to add those extra layers to our animator that will see her use different animations as she becomes more damaged, and they will override these animations in the base layer. I mean, basically those upper body and lower body animation layers that we're going to make will be mirrors really of what's on the base layer, except that different motion fields will be used, and the walk and the jog will be replaced with a kind of a really limpy walk and a really limpy jog. But anyway, that's the conversation for another time. Let's go back to our script and carry on adding some new stuff. So I also mentioned that we don't really have all the animations that we need to cater for all the different situations that Jill may find herself in. For example, if Jill is currently feeding, then we're not going to have an animation that has her taking damage to the side and sort of rolling over from a feeding position. So what I say in Dead Earth is when any animation is running on the cinematic layer. Now remember, at the moment our cinematic layer literally just has this eating sequence on it, but later on we're going to have a lot of other things on here as well, such as the animations that allow us to get back up from a ragdoll and a few other things as well. Now, I think I said either at the beginning of this lesson or maybe at the end of the last lesson that we obviously haven't got all of the animations that we need to perform kind of step back and hit reaction animations for every state that Jill might be in. I mean, we know what our hit layer looks like, and it basically has reaction animations for hits to the head, left, center, and right, and hits to the body, left, center, and right. And even then, it's only hit reactions when she is attacked from the front. When any of the animations are playing on the cinematic layer, we're not going to have any of the correct hit reactions, so we always want to ragdoll Jill if any animations on this cinematic layer are playing. And what we're going to do is use a state machine behavior for this, and we're going to add this state machine behavior to this empty state on the cinematic layer, okay? Which means that whenever a cinematic sequence plays, we are going to transition out of the empty state, and our state machine behavior will tap into the event that sees us exiting this state, and will then know that a cinematic sequence is being played, and then it will contact the state machine of our zombie and set some cinematic enabled boolean to true. Then in our take damage function we can simply say if we've been hit, then irrespective of whether the hit has any force applied or whether we would normally ragdoll, if that cinematic enabled boolean is set to true, then we know that one of the animated sequences on the cinematic layer is playing out, and we simply always ragdoll Jill. Doesn't mean she's dead, she'll get back up again, but we're just not going to have all of the animations that we need to cater for hit reactions in all of these various cinematic sequences that we're playing. So the way that we're going to do that first of all is with just a quick reminder of how we do that, because it's a pretty easy thing to do. You will recall that we've already created some state machine behaviors already. We have this root motion configurator that we use, and that's derived from AI state machine link. So let's just remind ourselves what AI state machine link is. It's the base class for all of our state machine behaviors, and all it has is a single member called state machine that stores a reference to our AI state machine base class. Furthermore, if we call up our AI state machine base class and scroll down to the bottom of its start function, you can see one of the last things it does is it contacts the animator component, and it says to the animator, I want you to give me all of the state machine behaviors on all of your states, on all of your layers that in this case are derived from our AI state machine link class. It gets an array of all of those script references, which we then iterate through, and we set its state machine variable to this state machine. So that's how we can have any scripts on any of our states and any of our layers in our animator talk to this state machine. So what we need to do is just create a new script derived from AI state machine link, and then we can add it to our empty state here in the animator. I'm going to call this new script Cinematic Enabler, and you'll see how it's going to work in a minute. So I'm going to create a new C# script. Like I said, I'm going to call it Cinematic Enabler, like so. And then I'm going to open it up in MonoDevelop, and I'm going to make sure that it's not derived from MonoBehavior, but it's derived from AI state machine link. And we'll get rid of the start and update function. We don't need these. These are MonoBehavior functions, and this isn't a MonoBehavior. But of course, what the state machine behavior class does have is the onStateEnter function and the onStateExit function. And these functions will be called by Unity automatically. When we enter the state for the first time, this function will be called, and when we transition out of the state, this function will be called. So what we can do now is if we save that off, it won't do anything yet. If I go back to the editor, we now have a valid cinematic enabler, and if I select the empty state, choose add behavior, and then choose a cinematic enabler, we know that in the start function of Duel's AI Zombie State Machine, it's going to fetch all of these behaviors, including this cinematic enabler script that we've just added, and it's going to set its state machine variable so that that script now has a reference that we can use in these functions to talk to the AI state machine. So what we'll do first of all is we'll add two variables at the top, both bools. They'll be public, so we can set them in the inspector. I'll call the first one onEnter. We'll set them both to false by default, and I'll call the second one onExit. And what these two booleans will tell us is what we wish to have that cinematic enabled boolean in our AI Zombie State Machine, which by the way is a property we haven't added to that class yet. What we wish it to be set to when we enter this state, and what we wish it to be set to when we exit this state. So what we'll say inside the onStateEnter function, we'll simply say if we have a valid reference to that state machine variable, remember, which is declared in the base class, then we will say state machine, and we'll just pretend we've created a boolean property in the AI state machine base class, and we'll pretend it's called cinematic enabled, right? And we'll set that to whatever we wish it to be set to in the onEnter function. So we'll set that to onEnter like so. And it's showing up red because obviously that property doesn't exist in our AI state machine class yet. We'll add that in a minute. And we're going to do the same thing in the onExit function, but this time obviously the cinematic enabled property will be set to whatever we want it to be set to in the onExit boolean. Of course, these two booleans are public, so they're going to show up in the inspector of this state machine in the animator window. So, well, you'll see what I mean in a minute. Let me just say state machine dot cinematic enabled equals onExit, and then we've got total control then of how we wish it to be configured. So we could put this script on another state that says we want the cinematic enabled boolean to be set to true when we enter it instead of when we exit it. But for now, we're just going to put it on the empty state in our animator, and we're going to have it set so that when we enter this state, it's set to false. But then when we exit that state, remember, on the cinematic layer, it means we're transitioning to a cinematic sequence. So we will set this to true in the inspector so that our state machine will now know that a cinematic sequence is playing, and will know that in its take damage function, if this is true, then if it gets hit by anything, it should instantly ragdoll it. Now, of course, we're not going to be able to sort of test this out yet because we need to go and add this cinematic enabled property to our AI state machine base class. So let's do that now. I've opened up my AI state machine.cs file. I'm going to scroll down to where the definition for the AI state machine class is. I'm going to create a new protected boolean called cinematic enabled, and I'll set it to false by default. And then if I scroll down a little bit under where we have these other properties for things like target collider ID, I will create another property with both a setter and a getter this time. It's going to be public. It's going to be of type bool, and I'm going to call it cinematic enabled but without the underscore. And obviously the getter will simply return the underlying member variable, and the setter of course will simply set it. So cinematic enabled equals value, like so. So now we have this function implemented in the base class. If I go back to that cinematic enabler state machine behavior, that error is now gone. And if I go back now to our editor and select our empty state, you can now see in its inspector we have the cinematic enabler script on it with those two serialized public booleans where we can configure how we want the cinematic boolean in the attached state machine to be set. So in this particular case, when the scene first starts, there won't be a cinematic sequence playing, and the empty state is the default state. So when we enter this state for the first time, or whenever we re-enter it, we always want that cinematic boolean in the attached state machine to be false, so we won't tick it, okay? But the minute we transition out to any of the states that are either here now or the ones that we're going to add later, it means a cinematic sequence is playing. So when we exit this state, we do wish that cinematic boolean to be set, which is why I set it to true there. We're saying set the boolean to true when we leave the empty state, and make sure when we're in the empty state it's not set to true. And that's what's really cool about the scripts that we derive from AI State Machine Link and the associative support code that we added in the AI State Machine start function, is it just allows us really easily to create a new state machine behavior, add it to any of our states in the animator, and that script has access automatically to the AI State Machine class that it's attached to. So it can configure any of its properties, call any of its functions. And you're going to see that being used a lot when we develop the first-person ARM system. It's going to be a lot of communication between the rather complicated animator that we're going to need to create for that, that's going to handle all the weapons, and how it's going to talk to mono behaviors to tell it when things like objects need to be turned on and off and things like that. So make sure you really understand how the communication between the state machine behaviors and our mono behaviors, in this case our AI state machine, is happening, because we're going to be using this method a lot going forward. Okay, so I'm now going to go back to my AI zombie state machine class, which you will remember we just added the lower body damage and the upper body damage variables, which describes the amount of damage the zombie has received in the 0 to 100 range for the associated region of the body. Now we're going to add a few more serialized variables here that will allow us to configure the zombie even further, but some of this is going to be a little vague at the moment because it's not really until the next lesson when we're going to add some more layers to our animator so that we can see the upper body damage and we can see the lower body damage visually play out. So for now, just bear with me and I'll try and briefly describe what I'm doing the best I can, but like I said, some of this won't really be used until the next lesson. So the next variable I'm going to add is going to be a variable called upper body threshold. It's going to be a serialized field. Once again, I want this to have a range slider in the inspector in the 0 to 100 range, and it's going to be an integer. And by default, we'll set it to 0. Now, as described, in the next lesson, we're going to add more animation layers to Zombie Jill's animator. One of them is going to be called the upper body damage layer. And this layer is going to contain all of the walking and turning and running animations that Jill should use when she has upper body damage. When Jill has received the appropriate amount of damage in the upper body, such that we want to manifest it visually in the way that the zombie is walking and running, we will fade this layer's weight from 0 to 1, so the animations in this layer will override the upper half of Jill's skeleton. So what is the appropriate amount of damage? We don't want Jill to be walking looking like she's got a really damaged upper body if she's only received 1% of damage to that region of her body. So that's what this upper body threshold is. If we set it to say 30, for example, then what we're saying is once her upper body damage climbs past 30, we are going to activate the upper body layer in the animator, which, like I said, will override any of the animations that are trying to animate the upper part of Jill's hierarchy in the base layer. And 30 is actually a pretty good default. Now for the lower body, we actually want two thresholds. We want a threshold which I call the limp threshold, which is going to be used to tell the animator when the lower body layer in the animator should be used to override the bone animations of the base layer for the lower part of the skeleton. But then we also want a secondary threshold, which I call the crawl threshold, which will describe when we no longer wish to use any of those layers because the zombie's no longer walking and we wish to force it to a crawl instead, which allows us to describe to the system at which point we're not going to use the limping animations, but we're going to turn our zombie into a crawling zombie. And I put it at 60 by default, but I think that should probably be higher. I mean, we want her legs to almost be completely smashed to bits before she can no longer walk. So I think I'll probably put this at like 30 and 90. But these are just default values. If I go back to the editor, select Zombie Jill's AI entity, and then scroll down to the Zombie State Machines inspector, there you can see we have the upper body damage threshold set at 30, the limp threshold set at 30, and the crawl threshold set at 90. So we've got to really smash her legs to bits before it will force her to a crawl. But the upper body threshold and the limp threshold won't do anything at the moment because we haven't added the lower body and upper body layers to our animator. We're going to do that in the next lesson. I only added these now because I do need the crawl threshold, as you'll see in a minute when we are updating our take damage function to decide when we need to ragdoll. So now if I go back to my AI zombie state machine script, I'm going to create a property that's going to allow any object to inquire about whether this zombie is in a crawling state. And of course we know the zombie is going to be in a crawling state when the lower body damage is larger or equal to the crawl threshold. So let's go down to where all of our properties are defined and let's create that property here, and it only needs to be a getter. So it's going to be a public property of type bool called isCrawling. It's going to have a getter that simply returns lower body damage is larger or equal to crawl threshold, like so. And you're going to see us using this property in a moment in the take damage function, because one of the things the take damage function will do is it will check if we are currently crawling, and if we are crawling, then it will always ragdoll the zombie. And the next function I'm going to create is going to be a function called update animator damage, and this function will reconfigure the animator if it needs to be reconfigured to reflect visually what the new damage state of the zombie is. So in the case where the legs are now very damaged, it will set the crawling boolean in the animator, and then eventually when we add our upper body damage layer and our lower body damage layer, it will also check the damage to the upper and lower body against the thresholds, and it will also set some parameters in the animator that will bring up the weights of those layers to override the base layer. But we can't do any of that yet. So for now, the update animator damage function is simply going to set the crawling boolean if we are currently crawling. So where shall I put this? I'll put this under the update function down here and above the take damage function. So it doesn't need to be a public function, so we'll make it protected. It's got a void return type and it's called update animator damage, like so. And like I said, for now all we can really do is just check we've got a valid animator and then check if we are in a crawling state, and if we are, just make sure that if I go back to the editor, that this crawling boolean is set in the animator, which we've seen in our base layer will actually see us transition into the crawling locomotion. So we will say if animator doesn't equal null, then animator set bool, and actually we want to use the hash version of this function, so we'll create an integer and store the hash. So we'll call this crawling hash, and then we'll just call that property that we've just created, like so. And then we need to go up and create this variable here called crawling hash. That just needs to be a private variable. So we'll say private int crawling hash equals, and then we'll use the animator's string to hash function. Of course, we need to pass in the exact spelling and capitalization of our parameter, which is crawling with a capital C. Okay, so the only thing we have to do now is we need to make sure that from our start function we also call this update animator damage, because if we have configured Jill such that she starts off with a really high amount of lower body damage, then that should force her to a crawl instantly. So let's try that. Let's put lower body damage up to about 100. That'll definitely be past the threshold. So we'll need to create a start function. This needs to be an override because obviously there is a base class implementation, so we'll need to make sure we call that also. So the first thing we'll do is we'll just do base.start like so, and then we'll put our call into update animator damage like so. Save that off, just go back to the editor and check I haven't got any errors. And then let's press play. Actually, let's just press play without it first of all. Let's put the lower body damage threshold down to 0, press play, and she should walk normally. There she is, just doing her thing. But then if I stop it again, put lower body damage threshold up to, well, just anywhere past the crawl threshold, so 100, and press play again, we should see her immediately now starting a crawl. So now we've got the ability to configure each of our zombies in the scene at startup just using our AI zombie state machines inspector and these slider bars. So even if we have two zombies that are exact clones of each other, they won't look like that, because we can just say, well, we want this one to start crawling, we want this one to start fairly healthy, and obviously once we've implemented those damage layers, we'll be able to say, well, we want this one to start with lower damage, so it might walk with a limp initially, and if one's got upper body damage, we might say we want this one to sort of walk normally but have its arm hanging down like it's dislocated. But of course this all depends on the animations that you can find to do these things, but it gives us pretty much flexibility with just this animator. And then what we'll do later on when we want to create lots of different variants of the zombies, because we don't want all of our zombies acting the same, is we can just clone the OmniZombie1 animator controller, call it OmniZombie2, and then we can just find other zombie animations, and then using the duplicate of the state machine, just change all the motion fields over to use different walks, different turns, different runs, and then we'd have to set up all these different animators for different zombies because they all just share the same state graph, they just have different motion fields. So let's now revisit the take damage function of our AI zombie state machine class that we wrote in the last lesson, because it was pretty placeholder. Now don't get me wrong, most of the stuff we wrote can stay, but we need to add a lot more to it. Just to recap, at the start of the function we emit some blood particles from the point of impact, then we subtract the damage done by the weapon passed in as a parameter from our health. This line is going to need to go because we now know we only want to subtract damage from the health when the damage has been done to the head. Then we calculate whether any force is being applied by the weapon, or if health has dropped down to 0, and if it has, then we set should ragdoll to true, and then in the should ragdoll conditional, we X out of any state our AI zombie state machine might currently be in, set the current state to null, disable the animator, the nav agent and its collider, set in melee range to false, and then we iterate through each of the rigid body parts of the zombie that we collected in the start function, changing their kinematic property from true to false, meaning that those bones will now be controlled by Unity's physics system instead of the animator. Finally, if there is a force to be applied, we add that force to the body part. Remember, the body part that was actually intersected by the weapon is also passed in as a parameter to this function. So what we're going to do first of all is we're going to delete that line of code that says health minus equal damage, because like I said, we're going to add some code that's only going to do that if the damage has been done to the head. And the first thing I'm going to create in this function is I'm going to create the conditional that is executed if our zombie is already in ragdoll mode. Now remember, just because a zombie is a ragdoll doesn't mean it's dead. In the next lesson, we're going to work on our reanimation system that is going to see our zombies transition from ragdolls back into fully animated zombies. But if a zombie's in a ragdoll state, we certainly don't want to ragdoll it again and do all this code again. Furthermore, we really want to make sure that even if it is ragdolled, we still apply a force to it, so that if we have even a dead zombie on the floor and we shoot it in the head with a shotgun, we see the head or the body move under the force of the blast. Finally, in the case where it's a ragdoll, we still wish to apply damage. Like I said, just because the zombie is ragdolled doesn't mean it's dead. So if the zombie is on the floor, just about to reanimate again, and we shoot it in the head or shoot it in the legs, we still wish to apply that damage. So one of the things we added to this class a moment ago was the AI bone control type enumeration. And we're going to use this to determine whether we're in an animated state, a ragdoll state, or in the next lesson, a ragdoll to anim state. So let's use that now. Let's go down to our take damage function, and right underneath where we emit the blood particles, we will create the conditional that says if bone control type equals AI bone control type ragdoll. Now obviously we haven't seen the code yet that sets bone control type. That's going to be down here in the if should ragdoll conditional, but we'll add that in a moment. So if we have ragdolled the zombie on a previous shot, we'll set it down here, and then up here the next time we shoot it, this conditional will be executed. So what do we want to do when the zombie is in a ragdolled state? The first thing we want to do is we want to check we've been given a valid body part sent into the function. And we also want to see if there's any hit strength here, because if there is, we still want to apply a force, much like we did in the ragdolling case, to the rigid body so that the zombie moves under the blast of the shot. So the first thing I'll do is I will copy that hit strength calculation. I'll cut it from where it is and I'll paste it above the ragdoll conditional, because we're going to need that hit strength inside this conditional. Inside the conditional, I'm going to check we've got a valid reference to a body part. So I'll say if body part doesn't equal null, like so. And then inside that conditional, we'll check we have a hit strength greater than 1. Because if we have, it means we wish to apply the force vector that we were passed in to the body part. So we will say, just as we did before in the case where we ragdolled our zombie, we will say body part dot add force. We'll send in that force vector we were passed as the second parameter to this function, and just like we did before, we wish to apply the force using force mode impulse. So next up, we want to check out what type of body part we've hit. So if we've hit the head, then this damage value we've been passed in needs to be subtracted from the health, just like it was before. But if we've hit the upper body or the lower body, then this damage variable we've been passed in needs to be added to our upper body damage or our lower body damage. So let's check first of all if we've hit the head. So we'll say if body part compare tag head. Let me just go back to the editor and check that I've got the capitalization right. I select zombie Jill, drop down my tag list. Yes, you can see it's upper space body, lower space body and head. So if the compare tag function here returns true, then it means the body part does have a tag of head. So we'll step into this conditional and we will subtract the damage that we've been passed in from our health. We'll also make sure we clamp it to 0. So we'll say health equals mathf.max health minus damage, just like before, comma 0. Okay, so health can never drop lower than 0. So if the body part we've been passed doesn't have the head tag, let's next check to see if it's got the upper body tag. So I will say else if body part compare tag upper body, like so. And of course in this case we don't wish to take the damage away from the health, we wish to add it on to the upper body damage. So we'll say upper body damage plus equals damage, and you can probably imagine what the final clause is going to look like. I'll still put the if in there just in case we create some other types of body tags. I'll say if body part dot compare tag lower body, then of course we say lower body damage plus equals damage. So even when our zombie is ragdolled, it doesn't mean that when we shoot it it's not doing anything. We can still, if we have a zombie down on the ground and we're not sure it's dead, we can still try and shoot it in the head to make sure we definitely finish it off. And likewise we can shoot it in the legs and it will still apply damage to the legs. And then if the zombie is reanimated, it might get back up again, but now when it comes after you, it will be limping towards you. And now we've altered the upper body damage, the lower body damage and the health, which could of course mean that when the zombie reanimates it should be either limping or crawling. What we should do is call our update animator damage function. That's the one we wrote just now, that's going to take care of making any changes to the parameters in Jill's animator so that when she wakes up it correctly reflects the way that she should be either walking or crawling, etc. Now obviously we saw that function just now doesn't do a lot at the moment, it just sets the crawling boolean to true if the zombie's lower body damage is larger than the crawl threshold. But in the next lesson we're going to add some more code in here that's going to set up those additional layers. Actually it probably won't be the next lesson. The next lesson I think is going to have to be the reanimation system first, and then after that we'll come back and we'll add in those damage layers. So what we've done in the ragdoll case at the moment is we've applied the damage, we've updated Zombie Jill's animator so that any of the damage we've caused can change her visually as she animates. All that's really left to do now is to check her health, and if her health is larger than 0, then it means that she should be reanimated. Now we haven't written the reanimation system yet, so for now we'll just put the conditional in place with a to do. So we'll say if health is larger than 0, and I'll just put a to do in there, okay, as a comment, and I'll say to do reanimate zombie. And that's that conditional done. So outside of this we will simply return, okay? Nothing else in this function has to be processed in the case where we shot the zombie and it was already in a ragdoll. That is it right there. Okay, so next up we're going to process the code now where she's obviously in an animated state, or perhaps in a ragdoll 2 animated state, and we need to find out whether we need to ragdoll her or whether we need to play one of those pre-canned step back animations. Okay, so underneath the conditional we've just written, I'm going to calculate the local space position of the attacker. Now the attacker is of course the character manager that's been sent in as a parameter, and I want to determine whether the attackers come from behind the zombie. That's why I'm getting the local space position of it, so that I can just check the Z component of that position. And if it's negative, then I know that this zombie was shot from a character that is stood behind it. So it's an attack from behind basically, and we know that when it's an attack from behind we always want a ragdoller. So let me calculate that vector first. So I'll say vector 3, I'll call this attacker local pos, and in order to get the local position we just say transform inverse transform point, and we get the transform of our character manager and then get its position. Okay, so we pass in the position of the character manager into the zombie transforms inverse transform point function, and what we get back is the position of the character manager relative to the zombie. So if the character manager was like 10 units behind the zombie, then the Z component of this vector would have -10 in it. I'll comment these up a little bit more before I put them in the zip file for you. Alright guys? Now the next thing I want to do is I also want to get the local space position of the point on the zombie that's been hit. Now we are past the hit point as the first parameter to the take damage function, but this is a world space position. I want that in local space. I want to use that to determine whether the zombie has been hit to the left, to the right, or in the center, and that's going to influence which one of those reaction animations I choose from our hit layer. So I will say vector 3 hit lock pos for hit local position, and of course we use the same function again, transform inverse point, only this time we just send in that position vector that we were passed in as the first parameter to the function, and I'll put a comment in there saying get local space position of hit. I'll also put position in that comment up above. I forgot to put position in there. Okay, so we now have the local space position of the attacker and the local space position of where on the zombie it has been hit. Okay, so this next line can stay where it is. This is where we just calculate whether hit strength is larger than 1, and if it is, we set should ragdoll to true. But I'm going to get rid of that line underneath it at the moment. We don't want to set it to ragdoll here. We'll do this in a test a little bit later on. So just like we did above in the non-ragdolled case, we need to just sort of check the body part and what body part we've hit. So I'm going to kind of copy all of this code over, I think, because I can probably reuse quite a bit of it. There you go, that gives us a pretty good place to start. Now we need to take away this add force because we don't even know whether we want to ragdoll yet, and we've already got that being applied down here where we've already decided we want to ragdoll, so we'll get rid of that. Now in this condition here where it says if body part is the head, then we will subtract from our health the damage, and here we will say if health equals 0, then should ragdoll equals true. So we just move that line from here down into here. Okay, so in the case where it's the upper body, we do the same thing. We add the damage to the upper body, and actually I think I will call update animator damage from there. Animator damage like that. I just want to keep these a little bit separate so I can see everything what's happening, and I'll cut that one out and put that in lower body damage as well, like so. I don't want to leave it outside there because there's absolutely no need for us to update the animator damage in the case where we've done a headshot that's killed the zombie. But in the case where we've hit the lower body, what we're also going to do is always set ragdoll to true as well. Because remember, we said if you do a leg shot, the zombie will always ragdoll. So you can see so far in the case where we're in animated mode and we take a shot, if it's the head, then we do what we did before. We subtract the damage from the zombie's health, and if health equals 0, we ragdoll. In the case where we've hit an upper body part, we add the damage to the upper body damage and we configure the animator. And in the case where we've done damage to the lower body, we add the damage to the lower body. We update the animator damage again, but we always set should ragdoll to true. So we now know that this is always going to ragdoll when we do a leg shot. We can get rid of that if health equals there. We don't need that here at the moment in this conditional. So that's our testing of body parts done. What we want to do now is a conditional that just checks that we're not either crawling, or we're not playing a cinematic sequence, or the shot didn't come from behind us. If any of those things are true, we also want to set should ragdoll to true. So let's do that conditional now. Okay, so the first thing in this conditional we're going to check is if bone control type doesn't equal animated. If it doesn't equal animated, then we definitely want to ragdoll it. Now in the case where it's a ragdoll, we'll never get here because this code up here will be executed. But in the case where we are currently transitioning from a ragdoll to an animated zombie, then we definitely want to just ragdoll it again. Think of this as a zombie trying to get back up onto his feet, and then you shoot it again. So that's one of the conditions under which we wish should ragdoll to be true. Or if we are crawling, we definitely want is ragdoll to be true. Or if cinematic is enabled, which remember is set from our state machine behaviors. And finally, or if attacker local pos.z is smaller than 0, then my friends, that also wants to have should ragdoll set to true. So all of the cases now where we should ragdoll have been set. So just to recap all this, if we are not a ragdolled zombie, if we're an animated zombie, these are the things that will make us ragdoll. If the weapon has a hit strength greater than 1, if we've been hit in the head and that's reduced our health to 0, if we've been shot in the legs, if we're currently trying to get back up from a ragdoll into an animated state, if we're crawling, if a cinematic sequence is enabled, or if the attack came from behind. Okay, so next up, let's handle the case where we shouldn't ragdoll. In other words, when we wish to play one of those reaction animations from our hit layer. So I'm going to create a conditional here that says if not should ragdoll. I'll put that in there like that, and then of course I need to do an else now to execute the if should ragdoll phase, but we don't need to do that test, right? Because if not should ragdoll is not true, then this condition is always going to be true. So we're doing a test there when it's just a straight binary option. So what we're going to do inside this conditional is we're going to take the local position of where we've been hit, and we're going to measure the angle against our zombie's sort of forward facing vector, and that will give us a pretty good idea about whether we've been hit to the left, to the right, or in the center, and then that's then used to trigger the correct animation. Now you will also remember that as the final parameter to this take damage function, we pass in a parameter called hit direction, which is an integer. This is going to be used when we have our arm system in place, and we're going to have state machine behaviors on our melee animations that are going to tell us what hit reaction we should play. And the reason we need to do this instead of just auto-calculating it like we will do for standard ranged weapons is that in the case of, let's say, a gun, right? We shoot the zombie, we detect that the zombie's been hit in the left side of the torso, and we're going to play a hit back reaction animation that has a stepping back and to the left, for example. That works fine. But now let's think about a melee animation where you are swinging, let's say, a crowbar from right to left, where we would fully expect as that crowbar makes contact with the zombie would be violently flung to the left, the same direction the crowbar was swinging. But with melee weapons, what really happens behind the scene is it's just an animation playing out, and when that animation gets to a certain point near the center of the screen, we just cast a ray through the crosshair. So we could be playing a really violent right to left animation with a crowbar, but we might actually hit the zombie on the left side of the body. If we just use the auto calculation logic, we would see the zombie stepping or falling the wrong way. So what we do is when we have our arm system, the melee weapons themselves will tell this function via the hit direction parameter exactly what reaction we should play based on the direction of the animation. But when it's not a melee animation, what we do is we just calculate it by saying, hey, if it's a hit on the left side, then you always play a left hit reaction, and if it's on the right side, a right hit reaction. So hopefully that makes sense. So let's get on with the code now by stepping into our not should ragdoll conditional. So first thing I'll do in this conditional is I just need to create a signed angle from the center of the zombie to the position where it's been hit. So I create a vector 3 called vector hit, and the vector is simply the position of impact of the hit minus the position of the actual zombie, its origin or center point, and I get the normalized result of this. Next thing I'm going to do is send that in to our find signed angle function. You may remember that is a static member of our AI state class. So I say angle equals AI state find signed angle. I send in our vector from the center position of our zombie to the position of impact, and I measure the angle between that and our forward vector. We're just trying to find what that angle is because that allows us to know if it's negative, it means we've been hit in the left side. If it's positive, it means we've been hit on the right side. That may be the other way around, I'm not sure, but we'll find out when we run it in a minute. Now for the next section of code, I think it's going to be easier if I just paste it all in and then talk about it. It's where we decide which one of these animations in our hit layer we are going to choose. So remember, this has got a hit ID of 1, of 2, of 3, 4, 5, 6. And here's the code that's going to decide which of those animations we're going to play. So as you can see, we create a local variable called hit type, and then we do two conditionals and we process it differently whether it's the head we've been hit in or the upper body. We don't have a conditional for the lower body because remember, we've already decided that if the lower body has been hit, this code won't be executed and we will always ragdoll because shots to the legs cause ragdoll. So inside the conditional where we say yes, we've hit the head, we measure that angle and we say if it's smaller than -10, if it's a negative angle, then hit type equals 1. And in a minute you're going to see that this hit type variable is what we're actually going to send in to our animator as this hit type parameter. And we know that those conditions are all based on the hit type. So if hit type equals 1, what we're saying is play this animation here. We're saying play the left hit to the face or the head. And as you can see, if the angle is larger than +10, then we select the right face hit. And if it's between -10 and +10, then we're saying, well, this is basically being hit pretty center on. So we're going to set that hit type to 2, which will cause this central face hit animation to be played. And you can also see here that we do pretty much the same thing for the upper body, but obviously just shifted by a value of 3 so that we're accessing the animations on the second row of the animator. And notice for the upper body, we actually use a wider angle threshold just because the body's bigger and it causes more variation. So we're saying if it's between -20 and +20, then we'll play hit type 5, which is this zombie hit straight center in the chest. If it's smaller than 20, we do hit type 4, which is this one here, the left body hit. And if it's larger than 20 degrees, we do number 6, obviously, which is this right body hit. So all that's left to talk about in this block of code here is the OR condition here, where we use that hit direction parameter. And as you can probably see already, what basically happens with our melee animations is they will either send in a value of -1 for a right to left hit or 1 from a left to right hit. So it's pretty easy, right? If the hit direction is -1, then we want to do that left hit. If it's +1, we want to do a right hit. And our melee weapons will always be either left or right hits. And you can see if we've hit the body, then the same thing applies, but once again, if it's -1, we do a left body hit, and if it's +1, we do a right body hit. So you hopefully get an idea now of how that hit direction is used, or in the case where it's not a melee weapon, we sort of calculate the hit direction by using the hit position and the angle to the hit position up here. But obviously that hit direction will be completely ignored. It's always going to be 0 until we develop our arm system, which is way down the road from where we are now. So finally, now we've calculated the hit type, we want to set the hit type in the zombies animator and also set the hit trigger. Just to remind you, this is the hit type parameter and this is the hit trigger, which when we set will trigger one of these transitions to be played based on the hit type that's set. So in order to do that, we of course need to create hashes. Well, we don't need to, but we should do for efficiency. We should create hashes for these two parameters, hit and hit type. So let's go up to the top of the class definition and do that here. Right here we'll say private int hit. I'll call this hit trigger hash, and we say animator string to hash. It was just called hit with a capital H. Remember, that's the hash for the trigger. And we also need to create another hash for the hit type, don't we? So I'll call that hit type with an underscore. Once again, animator string to hash. Let me just double check it was called, yeah, hit type, no space in between it. So hit type like so. And then if we go down now back to our take damage function, under where we calculated the hit type, we can say if we have a valid animator. And if we have a valid animator, we want to say animator set integer and send in that hit type. Oh, I call it hit type, not hit type hash. I don't like that. I'll go up and call it hash. I like to be able to see which of my variables are hashes just by looking at the variable names. So scroll back down and say set integer, hit type hash, and of course we send in the hit type that we've just calculated above, but that won't actually trigger anything. We've got to actually set the trigger as well, so we'll say animator dot set trigger, and for that of course we just send in our hit trigger hash like so. And in the case where we're not ragdolling, that is all we need to do, so we can simply return from the function. Okay, so in the case where the attack has not induced a ragdoll, we simply measure the angle between the zombie's forward vector and the vector from its center position to the hit point, and then we measure the angle to see which one of our hit type animations should be played. And then when we've calculated the hit type, we set the hit type integer in the animator and then activate the hit trigger. And remember, hit triggers will just stay on once. Once it's been processed by the animator, it will turn itself back off again. So we don't have to worry about kind of unsetting the trigger afterwards. And then we return. So all that's left now is what happens when we step into the this else clause, which is the code that ragdolls our zombie. If we execute this code, it means we want to do a ragdoll, folks. And of course, we've already put quite a bit of code in there, so we just need to add a few things here and there. So I haven't really got a lot to add here. All I need to do is just somewhere near the bottom, probably about here. I just need to set the bone control type to ragdoll. So I'll say bone control type equals AI bone control type dot ragdoll. And then what I need to do is I just need to check the health here as well and say if health is larger than 0, then it means we should reanimate. And of course, we haven't got the reanimation system in place yet, so I will put a comment in there that says to do reanimate zombie. And we'll do that in the next lesson. Okay, let me go back, check I've got no errors. So we should test this really, shouldn't we? Before I do that, let me just select Jill's AI entity game object, scroll down to her AI zombie state machine, and just check that we have the lower body damage and the upper body damage set back to 0. Because we put the lower body damage up earlier so that we could test that the crawling state was being set for Jill. But I don't want her to start in this test already crawling. I'm also going to just jump back over to my character manager's do damage function so I can examine how we set up the weapon that we're currently using. Yeah, that looks good. It does 25% damage. We can think of this really as being like a melee weapon, because most guns, if you shoot a zombie in the head, will do 100% damage. Just no doubt about it. But this is more like a melee weapon that's going to do 25% damage, so we'd have to hit it in the head 4 times to kill it, and it doesn't apply any force. But unlike a melee weapon, we've given it quite a long range, so it's like a melee weapon, but it's being fired. Of course, that's not how we would set it up in a real game. So let's see how this works. So obviously, the most preliminary test is if we shoot the zombie from behind, it will go down and ragdoll as it always did, right? Because any shots from behind or in the legs, take that girl down. Okay, so now let's have her coming at us with the light on and try and do some body shots and see her sort of recoil. You can see she, oh yes, it's working quite well. So now I'll get up close to her and I'll simulate if we were sort of having a melee fight, and you can see I'm kind of, oh, I actually killed her then. Let me do that again. Maximize the window. Come on, Zombie Jill. I just want, yeah, that's good. Smack on. Oh yeah. Now, one thing I've noticed, and I don't think it's going to matter in the actual game. Let me just see if I can do some headshots when I've got some distance from her. Come on, Jill, you got a flashlight on you. Come for me. Actually, no, it is okay, isn't it? Yeah, no, that's okay. I thought we weren't getting any root motion on the top row of animations on the hit layer, but it seems like we were. It looks a little bit like you can see the same thing repeating, but you could fill up your hit layer with lots of different alternatives of all the animations you can find. So for me, I'm just putting in the basic animations so that you can see how the system works, and then you can have a much larger range of hit reaction animations. Oh, I suppose there is something I need to try. I want my zombie to start feeding, and I want to shoot it when I'm feeding, because we know when it's feeding it goes into cinematic mode, don't we? And we also know that it should automatically ragdoll in cinematic mode. So it's going to take a while for it to get around there. Look, did I still leave that food there? Yes, the food is still there. And she should ragdoll straight away. Okay, so there she is feeding. Now I'm going to shoot her. Bosh, and she ragdolls. Perfect. Oh, and also, while she's ragdolled, I was going to say we should try, you know, shooting her, but of course this current weapon setup doesn't apply any force, does it? So let me just apply, I don't know, like 5 or something like that. Save that off. Press play again. We'll take her legs out instantly, so she'll ragdoll, and then we'll and then when we go up and shoot her, yeah, you know, we can see her moving as well. Yeah, there you go. We can see, as even when she's ragdolled, our ragdolled code is working as well, and she's having damage done to her even when she's on the floor, and we're seeing the physics system apply those forces to her limbs. Pretty good stuff. Okay, so I think I'm going to wrap it up there for this lesson. As usual, the scripts that I have modified and written today are available for download. They are in the Dead Earth channel's resources section. And in the next lesson, I think, I'm not quite sure, but I think we're going to be working on the reanimation system next, before we add the upper body and lower body damage layers to the animator. So thanks for listening, guys. I will see you next time. Bye bye now.